In this video, we're going to learn how to simplify fractions using shortcuts. The first shortcut that we're going to learn is by looking at the numbers and noticing if they both are an even number, meaning that the last number is divisible by 2. Since we have 4 and 4, we know that we can divide this by 2 on both top and bottom. When we do that, and we know 64 divided by 2, and we could do this a long way if we need to, it would give us 3, and then we would have the 4, which would be 2. So we know that this would simplify to 32 over 124 divided by 2 will give us a value of 62. And we can keep repeating this step. We notice that it is both an even number for the top and bottom. So that means that we can divide this by 2 on top and bottom. If we do this one last time, 32 divided by 2 is going to give us 16. 62 divided by 2 will give us 31. Once we get to a point where we have a prime number, which is going to be 31, it means that we can't simplify it anymore. Prime numbers mean that you can't divide a number anymore other than that number. So the final answer would be 16 over 31. Now for this example, we have 108 divided by 243. Now we can't divide the bottom number by 2 because it's an odd value. However, we can still do a very simple trick. If we add each one of the digits for the top number, 1 plus 0 plus 8 will give us a value of 9. Whenever you get a number that is divisible by 3 when you add these digits, it means that the total number is divisible by 3, meaning 108 is divisible by 3. So any value, 3, 6, 9, 18, 21, and so on, would tell us that is possible. Now, if we do the same thing to the bottom number, we're going to get 2 plus 4, which is 6, plus 3, which is 9. Again, telling us that this number is divisible by 3. If we divide this top number, 3 and 108, we're going to get 3, which is 9. Subtracting gives us 18, which is 36. And the bottom number, dividing by 3, would give us 81. So we'll have 36 over 81. Now we can keep dividing by 3. If we added these digits, you'd see you have 9 plus 9 indivisible by 3. However, we can simplify this process by noticing that 36 is divisible by 9 and 81 is divisible by 9. If we simplify that, we're going to get 4 on the top and 9 at the bottom. Now we have to stop the process because 4 is only divisible by 2 and 2. 9 is divisible by 3 and 3. There's no value that's the same that we could divide top and bottom by. So therefore, the answer would be 4 over 9. Now, the other way we can simplify fractions is by figuring out the greatest common factor. Now, the greatest common factor is looking at the factor tree for each one of these numbers and figuring out what multiples they share. So we'll take a look at this number on the left, 154. Now, we want to do a factor tree, and a factor tree tells us what two numbers can multiply to 154. Well, we know we can do 2, and 2 times 77 would give us that 154. Now, we're going to factor out the numbers at the bottom individually. 2 is a prime number, so we can't factor that out. But we know 77 is a multiple of 7 times 11. And what this factor tree means is that if we took 2 times 7 times 11, that would equal to 154. And these are all prime numbers, and so it's prime number factorization. Once we get all the numbers that can be multiplied, it'll tell us what that number is again. Now let's do this to the 196. We're going to move this 196 over a little bit so we can have room on both sides for when we factor this out. Well, we know since it's an even number, it would be 2 times something, and if we do the math, it would be 98. 2 is a prime number, so we don't need to factor that anymore. Now, 98 can be factored by a 2 and a 49, and 49 is a multiplication of 7 times 7. And so now that we have all the prime numbers factored out, that means that 2 times 2 times 7 will be equal to 196. And what we'll notice is that we have some similarities. We have 2 and 2, and we have a 7 and a 7, meaning that 2 times 7 would give us a value of 14, which means that if we divided top and bottom by 14, we can figure out what our answer is. But there's actually a shortcut to this, is that if we take what the leftover parts are, that would be our answer. So since the 154 is on the top, it's the numerator, we take the leftover part, which is 11. 186 is the denominator, meaning the number on the bottom, and we have both a 2 and a 7. We multiply that 2 and 7 on the bottom, we'd have 14, and with those leftover parts, that means that this would simplify to 11 over 14. So let's do another example so we can show off this trick. We have this value of 143 and 325. The 143, it's not a prime number, and if we add the digits up, it would be 8, so it's not divisible by 3. But if we do some math and start dividing by prime numbers, we'll see that it is going to be 11 and 13. If we take the values over here, we know we have a 5, so we can factor out a 5, and then we would have a 65. Factor out another 5 because we know it ends in 5, and then we would get a 13. So the greatest common factor, or what we see common in both, is going to be a 13. But to simplify this, we're going to take the leftover parts, which would be 11 at the top, and we'd have 5 and 5 at the bottom. If we multiply that number at the bottom out, our answer would be 11 over 25. Now, if you wanted to go the normal route, since both 13 and 13 were found in both, that means that we would divide top and bottom by 13. But we know that if we divided top by 13, we would get 11 out of the top. And if we divided by the bottom by 13, we'd get a 5 and 5, which would be 25. So you could do it either way, but the quickest way is going to be taking the leftover parts, greatest common factor, to simplify your answer. Now, what happens if you have a large number? Say we have 864 divided by 1296. We can still do a factor tree, but the easiest way to do this is try to figure out the largest number that's divisible. Well, I know that 8 and 64 are both divisible by 8, and I'm pretty sure that we can divide that. 8 would go into this one time, and 0 and 8. Looking at this row, we can start with 8. We know that that's going to be 4 and 2, which then would give us 2 and 2 for that 4. For the 108, that's divisible by 4 and 27. So then we're going to have 2 and 2. We'll have 3 and 9, and then a 9 would be 3 and 3. Once we got down to all of our prime numbers, which in this case would be 2 and 3, we'd have our prime factorization, and so we can move on to the next number. I know that 12 is divisible by both 12 and 96, so we can divide out a 12. And again, that would give us a 108 on the other side, which we know is going to be 4 and 27. We'll have 2 and 2. Then we'll have 3 and 9 and 3 and 3. Then with that 12 here, we're going to get 3 and 4, which would then be 2 and 2. So next thing we're going to do is figure out what we have in common. We're going to figure out each one of our 2's. We have a 2 here and a 2 here, 2 and 2. Then we have a 3 and 3 and 3 and 3. That leaves a leftover 2, which is going to go on top, and a 3, which is going to go on bottom, and that would be our answer.